So so um, so we'll basically continue from here. If you guys have any questions about electromotive force or potential difference, please let me know. Okay. So now today we are going to go towards resistance, and let's see. So resistance is basically, well, there is no such thing as a proper definition, but you can write that resistance is basically voltage over current. Really, in the exam as well they're going to ask you this. So resistance symbol is R, and the SI units are ohms, which is written like this, and the formula of resistance would be voltage over current, just like this, right? All right. So now what you need to understand is that resistance basically comes from this Ohm's law, which basically relates current and voltage. So according to Ohm's law, it is basically states that voltage is directly proportional to current if temperature stays constant. All right. Now, so to test Ohm's law, we can basically set up a circuit. So what we can do is we can basically take supply. With the supply, we'll just take a variable resistor, and then you're going to add an ammeter to know the current flowing, and then we can put a voltmeter to check it, right? Like that. And whenever we basically change the resistance, when we change the resistance, the current in the ammeter will change too. So we can then prove that the voltage is really equal to the current times the resistance, and the voltage will be the same that is coming here. So we can check the current through the ammeter, we can see what resistance we've done to the variable resistor, and we can prove that. And basically this shows that when we draw a graph between current and voltage, so voltage in volts, current in amperes, it would give us a straight line like that. Okay, this kind of graph is basically a graph of conductors which follow Ohm's law, and basically this states that voltage is proportional to current. That's fine. All right, please let me know if you have a question here. All right. Now, there are different kinds of resistors that basically some of them follow Ohm's law, some of them do not. So we're going to learn about them. First of all, we're going to learn about a fixed resistor. And then we're going to learn about a variable resistor. So fixed resistor basically has a symbol like this, and a fixed resistor has a fixed value of resistance. So let's suppose if you go to a shop and you say that, okay, I want a resistor of value 10 ohms, he's going to give you a resistor that's particular value that doesn't change. And this is the reason why this would be a ohmic conductor, because it will follow Ohm's law all the time. Variable resistor, however, has a symbol like this. We've already done the symbols. So variable resistor has a range of resistances. For example, it could have 0 to 100 ohms. And basically it also follows Ohm's law. So you guys need to remember that. One of the variable resistors are like everywhere. So for example, if you look at in your room, you'll find that knob that turns on like the fan speed faster, like slower. You turn it, and basically it's a variable resistor where you're allowing more current to reach the fan so it can move faster, or less current so it can move slower. It depends on that, right? All right, now then we also have some semiconductors, and they are non-ohmic conductors basically, so which means they do not follow Ohm's law. So let's talk about them. The first one being the thermistor. Now a thermistor is like this, and the thermistor has some certain special properties. For example, when the temperature is high, it has a low resistance, so it can allow more current. And when the temperature is low, it it has a high resistance, so it doesn't allow current to really flow. Now, because of this, a thermistor can be used to basically be used in fire alarms. It can also be used in monitoring temperature, and they're everywhere. Like, when you set a temperature in your in your AC, like you want the AC to cool your room by 25 degrees, right? Or 225 degrees, and the outside temperature is 36 perhaps. So what it does is the thermistor basically controls that, and when the AC manages to make the room temperature exactly 24, it can actually trip the AC or slow it down. So it's always, controlling how fast or how much power the AC is going to take, depending on the conditions you've set, right? So that's something worth knowing. Also, in cars, you might have automatic climate controls that's also basically working because there are thermistors installed in that. Then you got a light dependent resistor that we call, I told you that we call LDR. So LDRs basically look like this, and LDRs are like when light intensity is high, which means that something is bright, so then it has low resistance, so it can allow current to move. And when light intensity is low, which means it's dark, so then it has high resistance. So the thing is that this is usually used in burglar alarms, because in security systems, when you put, you turn the lights off, you turn on the security system, they sleep. If somebody breaks into your house, and then of course to see in the dark he needs to switch on the light, the moment he's going to switch on the light, this alarm is going to sound, because then if there's light, it will start allowing the current to move through it, and the current can reach the alarm, and that can sound. Is it clear, everybody? Please let me know if you understand everything.
Yes, sir.
Okay. The next thing we're going to do, we'll learn about a diode. And a diode is a special kind of, electric component, which basically is like this. So diode basically allows current to flow in one direction only. So what I mean by this is that if suppose you put a DC source, positive terminal and negative terminal, and now you put a diode like this, and the wire goes through bulb, something like that. And then another student has done it like this. So because the current will go from positive, reach here, it will, if it's going from this sign, it will allow the current to go and the bulb will light up. But in the other case, when it's going here, it will not allow the current to go, which means the bulb will not light up. So this way you can actually change, you can actually control where the current should flow and where you should not. So then what you guys need to understand is that if you draw a graph of this, so it should be like in two-way. Like here you should have current, here we have voltage and negative voltage and positive negative current. The reason I'm putting a negative current is because we want to show the opposite direction as well. So it only allows the current to go in the positive direction, so it quickly rises up like this. But then in the opposite direction, it does not allow any current to flow. So as you can see that the current never flows in the opposite direction. So that is the graph. So this is the reason that you can use LEDs, which are basically use less energy, so they use less voltage, and then they can actually produce a lot of light, because the diode, when it's correctly functioning in the right direction, uses very less energy and gives out a lot of power. So that's why we could say that it's an ideal thing to have. All right, is it clear? In the sense that it allows large current to flow for a very small voltage. So you can remember that too. If you have any questions, please let me know.
Sir, can you repeat the last sentence that you just said?
Sorry? I just said that basically, if you look at this, it's using very little amount of voltage, but it's allowing a lot of current to flow. So basically, it uses less voltage, but delivers a good amount of power. That is the reason that it's like quite, LEDs cost you less electricity in general. Do you get my point?
Yes, sir.
Now, one of the major uses of an LED would be rectification. Now, rectification means basically changing an alternating current supply to a direct current supply. So that's basically called rectification. So what we do is, suppose, let me show you this example. So you have a source with alternating supply, and now it is going through sort of a bulb, right, like that. So if you connect a voltmeter and you try to make a graph, so the graph will show you that it's like going up and down like this. Is it clear? Now, we don't want that. We want it to become DC. So we have AC supply here. And now what you're going to do is you're going to connect a diode, and then you're going to connect a bulb. So now what it does is AC basically causes the current to go this way, and then in the other half it will go in the opposite direction. That's what AC does, keeps on changing the direction. But the diode will only allow the current to pass in this direction if it's placed like that. But then when the current tries to come from the opposite direction, the diode will not allow it. So then what will happen is that only one direction current basically passes, and it happens so fast that basically on an average like this you get sort of a rectified DC supply. Do you guys understand this? So if you look at it from the first graph and the second graph, it has just cancelled out the current that's coming from the opposite direction. So that's how, it works. If you have any questions, please let me know here. All right. So basically, this is how rectification is. And in A2, when you reach, A levels, you will learn how we can even make it even better, like smoother way of doing this. So there are like so many uses of this. But for now, you can just remember how I have converted two directions into just one. And that's called rectification. Okay. Now, one last non-ohmic conductor that we're going to do is a metal wire. A metal wire is also a non-ohmic conductor, especially ones like filaments, etc. So what metal wire does is, if you look at a metal wire, it has basically a very nice, okay, let me make it a bigger one. It has like particles in it. They're very nicely arranged in layers because it is sort of like that. And then when the current flows through it, because they're free sea of electrons, they just go from all the directions. These electrons, so has a sea of electrons, and that's what we learned in chemistry as well. So you guys need to understand that as the current flows, due to internal movement of sea of electrons inside a metal, friction causes it to produce heat. This heat causes temperature to increase, and because the temperature is increasing, Ohm's law cannot be followed, because Ohm's law basically must be like true if the temperature is constant, right? So increase in temperature also causes it to increase resistance, as the vibrations of lattice basically the arrangement of how the metal is, increases. Is it clear, everybody? Any questions? Let me know. So then, if I draw a graph of this, so a graph, so suppose we have current here, we have voltage here, current in amperes, voltage in volts. Initially, as the temperature increases, and then temperature starts to get limited because the current starts to get limited because the temperature is increasing, and now it uses a lot of voltage, and it doesn't allow more current to flow. So it becomes a curve like this, and that's the graph of a metal wire. Now, who has seen a okay, so who has seen a filament lamp, a filament bulb before in his or her life? Yes, Moise, Anaya, Rabia, Caroline, Zarish. Anybody? It's not possible that you guys haven't seen a filament bulb.
Sir, I've seen one.
Okay. So, have you seen an LED bulb then too?
Yes.
Notice that the LED graph is very like the diode graph is like this, like quite opposite of what it is doing. So, in your TVs, which might be LEDs now, so LED TV has around a power rating of like possibly 150 or maybe 200 watt, right? And there are like millions of LEDs in that screen, right? However, a small filament bulb which looked like this, actually like this, right? It had only one wire like this, and the rating would be from 60 watt to maybe 300 watt or something like that. So a metal wire basically uses a lot of energy, and the reason is because of the temperature, and because it causes it to increase its temperature, the resistance has increased. So to make the current flow, you need to put in a lot of energy, and that's how it is not a very um, nowadays energy efficient way to produce light or something. So yeah. Okay, now that's something I want to tell you now. So I hope you guys have written this. If you haven't, please let me know. Otherwise, I would like to go forward from here. All right. Now, because resistance is sort of a thing where it is dependent on, you know, metal wire, and the different components are made from wires. So we're going to learn how, when we're talking about a conductor that is metal, how it is affected by its length and area as well. So let's talk about that now. So, first of all, I would like to tell you that when you see a metal wire which is like this, okay, and let's suppose a metal wire is like this. There's a thick one and there's a smaller one. So it has a smaller area. This one has a larger area. So you guys need to understand that the smaller the area is, the current that is going into it will face more resistance, which means that the resistance is inversely proportional to the area. So it means that the greater the area will be, it is easier for the current to flow. And that is the reason that when you see like components using a higher, power, like for example a heater or an AC or something like that, they have thick wires. But your mobile phone, which uses very small voltage and current to charge itself, has a very thin wire. Do you guys understand what I'm saying? Okay. So imagine this. A lot of times, I talk about this with my kids. So who has gone and to McDonald's play place? Anybody has gone there in their life?
Sir, I did.
Okay, Anaya did. So Anaya, when I was like,
I still go there
you,
because of my siblings.
okay, that's cool. So when I was really really small, like this, small, I used to easily go in and then walk and have fun. Now I'm this big. If I want to go to the play place, I'd probably want to, fit like this. Otherwise, I won't be able to. Don't you think so?
So,
So it means that if you have larger current, that won't be, because the resistance of a small area is so much that you won't be able to. But if the play place were made for adults, I would still, probably walk into it. But it's not, unfortunately, right? Now imagine if somehow I did fit into it, and now this wire, this pipe that I'm going through is about 1 kilometer long. Won't I be tired? What do you say?
yes, sir.
So, I would be pretty damn tired, which means that if the wire is the short wire, it's not very long, then basically I will just go in, or the current will go in and come out of it really easily. So it means it doesn't offer that much resistance. So then resistance is directly proportional to length as well, because if the length is higher, then the resistance higher as well. So what I can say is the number one, higher resistance. Okay. In fact, I'll write it as greater the area, lesser the resistance. I'm talking about the cross sectional area. And then two is that smaller the length, lesser the resistance as well. So if I combine these two things, then resistance is directly proportional to, it's proportional to length and inversely proportional to area, like that. And when I remove this proportionality, I have to put a constant, and this constant is basically this rho, and that's called resistivity. Now resistivity basically is the measure of how resistive a material is, and it is a fixed value for each material. So naturally, good conductors will have less resistivity, and bad conductors will have more. So the SI units of resistivity are ohm and meters. You guys get my point now?
Yes, sir.
Okay. So so it's a fixed value, and you just need to remember that they will sometimes they will ask you to calculate it, sometimes they won't, so it's fine. But before we go there, we also need to learn how to basically solve ratios. So that would be the last thing we're going to do today. So let's look at some of the questions that I want you to basically see, and then I'll give you one question to solve itself. So you guys have written it. Should I go forward now?
Yes, sir.
Okay. So now let's look at something cool. So sometimes, for example, they say a metal wire of metal wire is made up of same metal wire P is made up of same material as metal wire Q. Okay. Then they say if P has 4 times the area as 4 times the area of Q and 2 times the length as of Q, what will be the resistance of P if Q has a resistance of 60 ohms? Do you guys understand the question? Now, these sort of questions, the first thing that you guys will notice is whenever they say the metal wire P or some other wire is made from the same material, you guys should remember that it means that the resistivity is of P is equal to the resistivity of Q. So you guys need to remember that, because if they're made from the same material, it means the resistivity is the same. And now what you're going to do is, as you know, the formula is that resistance is resistivity times length over area. So we're going to make a table. So we're going to write resistance, resistivity, length, and area. So we're looking at 2 wires, P and Q. So the resistance of P is what we need to find. So let's call it R. The resistance of Q is 60 ohms. They have the same resistivity, so I'm just going to write rho. The length of P is 2 times the length of Q, so we're going to write it like that. And it has 4 times the area of as Q, so we're going to write it like that, right? Then what you're going to do is you're going to make 2 equations. First for P. I'm going to write it here. For P, because the equation is rho L upon A, so resistance of P is R, resistivity is rho, length is 2L, and area is basically 4 times A. So that's our first equation. And then for Q, I'm going to make another equation. R equals to rho L upon A. The resistance of Q was 60, resistivity was rho, the length was length, and the area was A. Do you guys understand this? So that's your step 1. So once you made the equation, then in step 2, just divide P with Q. So if you divide it like you do these equations, P with Q, so what you're going to do is the resistance over 60 is equal to, now because we're dividing P upon Q, right? So we're going to write rho times 2L over 4A divided by, put this sign intentionally, I'll tell you why, and like this, okay? Now what you're going to do is, you simply, when you remove this sign, right? So you guys need to remember that you take a reciprocal. That's what you do in math. That's the same in physics. And when you take the reciprocal, A will be on top and resistivity and L will be at the bottom. And now it will help you cancel out stuff like resistivity cancels out resistivity, area cancels out area, length cancels out length. So ultimately you're left with R over 60 equals to 2 over 4. So R then will be equal to 2 over 4 times 60. That's equivalent to 30 ohms. So it means the resistance of P must be 30 ohms. Do you guys understand this?
Yes, sir.
So that's the most, say, safe way to get the answer, because then you won't be able to make any mistake. Otherwise, if you do it directly, like you say, okay, you could do that. I mean, if like the resistance of P you need to find, say, okay, 2 times length means the resistance will be twice, and then 4 times area will be, it will be quarter. So 2 upon 4 is half of the resistance of P or Q. So half of Q is 60, I mean 30 in this case. Though it's faster, but it will also cause you to have certain problems, so don't do that. But for all you guys who are interested that maybe you can actually get away with that, I'll tell you the other method as well. So if I were you, I would do, okay, I have this formula, R is equal to rho L upon A, right? I say, okay, if the length was 2, I multiply 2, so multiply 2 on the other side as well. And then I divide by 4 because area was times, so I've also divided by 4. So basically I get the resistance as 1 over 2 R. So then 1 upon 2, the resistance of Q was 60, so that would give me 30. That's basically less effort. But the thing is that you might get confused in sort of difficult ratios, so I would always suggest that you follow the step method 1. It will take some time, but it will get you the right answer. Alright then, any questions, please let me know now. Okay, fine. So here we're going to stop, and I'm going to give you a worksheet on this so that you guys are able to do these sort of questions, and then we're going to check it tomorrow. Let's hope that